Hello, fellow genetic gumshoes and history buffs. Welcome to a truly special episode of Decoding Dynasty. This is it, our 10th and final journey in this playlist, and what better way to wrap things up than with the most famous boy king of all, King Tutankhamun. For years, we've pieced together whispers from the past, used science to debunk myths, and revealed the genetic truths behind royal legacies. We've talked about what Tut didn't have. Remember, no Marfan syndrome, thanks to some stellar ancient DNA work. But that DNA didn't just rule things out, it shone a blinding spotlight on what did likely contribute to his frail health. Today, we're zeroing in on two specific genetic challenges that may have profoundly impacted Tut's life: the mystery of his clubfoot and the possibility of a cleft palate. These aren't just minor historical footnotes. They speak volumes about the genetic lottery he lost, largely due to a family tree that curled back on itself like a pharaoh's sacred cobra. So, for our grand finale, we're diving deep into the microscopic world of Tutankhamun's genes, exploring how inherited traits, amplified by generations of extreme inbreeding, left their undeniable mark on this iconic ruler. Get ready for one last incredible decode as we unravel the secrets of the boy king's true genetic inheritance. All right, detectives, we've set the stage for our grand finale, and now it's time to dig into the specifics of King Tut's actual genetic challenges, starting with something that literally shaped his walk through life: his clubfoot. Now, if you've ever seen images from Tut's tomb, you might notice something peculiar among his treasures: 130 walking sticks. Yes, you heard that right, 130. This wasn't just a pharaonic fashion statement. It was a glaring clue that our boy king had some serious mobility issues. And indeed, examinations of his mummy, particularly those fancy CT scans, have confirmed a significant deformity in his left foot, often described as a clubfoot, medically known as Talipes equinovarus. It's a common congenital condition where the foot is turned inward and downward, making walking, well, a bit of a heroic effort. So how does one end up with a clubfoot, genetically speaking? Turns out, it's not usually just one grumpy gene throwing a tantrum. Clubfoot is a complex beast with both genetic and developmental roots. We're talking about a whole team of genes and pathways that need to work in perfect harmony during early limb development. Think of it like trying to assemble a really intricate Lego set. If even a few key instruction steps are missing or out of order, the final structure just won't quite fit together. Scientists have pointed to several genes that are often involved when things go awry. We're talking about players like PX1, TBX4, and various Hox genes. These aren't just random letters, they're like orchestrators of limb formation, telling your leg and foot bones exactly how to grow and position themselves. If there's a mutation in one of these, or a combination of them, the foot can develop abnormally. It can also involve the very connective tissue and muscles we talked about earlier, giving us a whole tangled mess. And here's where Tut's family tree comes back into play. Big time. Remember how we learned his parents were full siblings? This extreme inbreeding significantly upped the odds. Even if a specific clubfoot-causing gene is rare or requires two copies, recessive inheritance, keeping it in the family makes inheriting problematic combinations much more likely. It's like playing genetic roulette with a heavily loaded dice. So when we look at King Tut's foot, combined with the bone necrosis, bone death due to poor blood supply, that also affected it, those 130 walking sticks aren't just historical artifacts. They're poignant evidence of a young man battling a debilitating genetic legacy that literally shaped every step he took. It certainly paints a different picture than the golden boy on a chariot. So, we've walked a mile in King Tut's likely very uncomfortable shoes, understanding how his clubfoot and bone issues made every step a challenge. But now, let's move up to his face, to another congenital anomaly that some researchers suggest may have also impacted his life: a cleft palate. For those unfamiliar, a cleft palate isn't about having an extra palate for snacks, though that would be convenient. It's a birth defect where the roof of the mouth doesn't close completely during early fetal development, leaving an opening between the mouth and nasal cavity. This can cause issues with feeding, speech, and even recurrent ear infections. Now, a crucial point here, detectives. While Tut's clubfoot is pretty well evidenced by his remains and those 130 walking sticks, The cleft palate for him is a bit more of a whisper than a shout in the scientific community. Some interpretations of his CT scans and skeletal evidence suggest it, while others are less conclusive. However, given the overall picture of his health, and especially that family tree shaped like a pretzel, it remains a very strong and plausible hypothesis. So, genetically speaking, how does a cleft palate happen? Just like Clubfoot, it's not usually the work of a single villainous gene. Cleft palate is typically multifactorial, meaning it's a complex tango between many genes and sometimes even environmental factors. Imagine building a house, and the genes are all the specialized contractors, the framers, the roofers, the plumbers. If too many of those contractors have faulty blueprints or are working a little sloppily thanks to genetic mutations, things might not align perfectly. Scientists have identified a whole parade of genes involved in craniofacial development, genes like GRHL3, ERF6, CDH1, and many, many more. These genes are crucial for guiding the delicate process of palate formation in the embryo, ensuring cells stick together properly and pathways signal correctly. If any of these get tangled, you can end up with a cleft. And what's the common thread here? You guessed it, that infamous inbreeding in Tut's family. When you're constantly marrying close relatives, you're not just concentrating the odds for one specific recessive condition. You're increasing the general genetic load. This means you're raising the chances of inheriting multiple subtle genetic variations that, when combined, can lead to complex developmental anomalies like a cleft palate. It's like rolling the genetic dice over and over again, and each time, the odds of hitting a problematic combination just keep stacking up against you. So whether it was his foot or potentially his palate, these congenital anomalies paint a consistent picture. A young king, born into immense power, yet grappling with significant physical challenges from day one, all thanks to a complex and unfortunate genetic inheritance. It truly makes his short life all the more poignant. And there we have it, my magnificent genetic gumshoes. Our incredible, sometimes stretchy, often wobbly journey through the mysteries of royal DNA is sadly drawing to a close. We've wrapped up our final case with the poignant story of King Tutankhamun, seeing how the incredible power of ancient DNA analysis, basically historical CSI with mummies, pulled back the bandages. We found a young king battling a painful clubfoot, the likely burden of a cleft palate, and a body weak from multiple bouts of malaria, all thanks to a family tree that clearly needed some serious pruning, and maybe a support group for its branches. Tut's story isn't just about a pharaoh's tragic curtain call. It's a loud and clear reminder that even with all the gold and power in the world, you can't outrun your genes. They really do write a heck of a story, proving that behind every grand title and golden mask, there was a real human being, often battling unseen genetic forces that even a pharaoh couldn't command. This episode, dear listeners, marks the grand finale of our Decoding Dynasty playlist. We've traveled more miles through history and genetic code than a pair of comfy lab slippers. We started with the pharaoh's earliest genetic secrets, puzzled over the royal woes of Henry VIII, peered into the hereditary challenges passed down by Queen Victoria and King George III, scratched our heads at the medical mysteries of Ferdinand I, and measured the unique conditions affecting Toulouse-Lautrec. Oh, and let's not forget the delightful complexity of Charles II, and that wild ride through the suspected Marfan connections of Paganini and Lincoln, before landing here with the final fascinating genetic revelations of King Tut and his family. Honestly, it's been an absolute thrill to unravel these historical puzzles with you, piece by genetic piece, like unlocking a very old, very complex safe. Thank you so much for joining me on every step of this decoding adventure. While the Decoding Dynasty series may be putting its magnifying glass away for good, the world of genetics is endlessly fascinating, and trust me, there's always more to explore. So, don't go anywhere. If you love these historical deep dives and cracking open ancient secrets, be sure to subscribe to The Geneticist for more mind-bending science, surprising discoveries, and the ongoing unraveling of the human genetic code. This may be the end of Decoding Dynasty, but our genetic journey together is just beginning. Keep those cells dividing and your curiosity sparking.